one, or is that coming?
The assignment that is up for this week, you mean? For this particular week, or the first week of this ancient history month?
First week.
What's that?
The first week.
I forget. You'd have to
Netflix?
No. I know, everybody gets all excited when they see that come up. There was the bull roar, there's the cave painting, and now there is the calendar, which I'm going to give you the stuff for. So those were the three things that I posted for this month. I didn't necessarily post them week by week. I'm just trying to get stuff out there when I can. So if you ever want something else to do, you let me know. Right? Okay, so welcome back. How's everybody doing? Me?
I'm tired.
Glad that it's the end of the week?
I'm tired.
You tired? Me too. And not getting enough sleep this week.
I'm always tired, so yeah.
You're not getting enough sleep either, are you?
Nope.
Okay, so last week we talked about the oldest stuff, right? We talked about the oldest art. We talked about the oldest tools. We talked about the oldest cities. We talked about the oldest people. And then at the end, we started talking about different types of calendars, right? We looked at Woodhenge, that the people at Cahokia built the big posts, and they measured where the sun was at different times of the year. And at the very end, very briefly, I showed you a picture of a site in Mexico called Chichen Itza, where they had this cool observatory, this round building. And through it, they were able to cite where the Maya, what we call Venus, rises and sets, northern and southernmost points. We call it Venus, they called it Kulkulkan, or the feathered serpent god. Yes?
If anybody is interested in stuff about like Mayans, there are some documentaries on like Disney Plus.
Oh, are there?
Yeah.
Oh, that's
yeah,
cool.
for teaching me stuff. So
I'll
yeah.
have to look at that. That's really cool. Thank you for that. And in the assignment that I most recently put out with the calendar, there's a series of links about everything we're going to do today if you want more. If you want more about glyphs, if you want more about Maya counting systems, and I'm going to look up Disney Plus and see if I can find those, because that would be cool to put
There
in
are
there
a
too.
bunch of them.
Okay. So what we're going to do today is we're going to start out short video about who the Maya are. You may know something about the Maya. It's a quick short video. You may not know anything. You may not remember. We're going to learn how to count to 20. Okay? Tough stuff. And then once we know those two things, then we can delve into how the Maya calendar works. Did I have any of you last year in enrichment in the math enrichment? Did we do the Maya calendar?
Yeah.
Cool. And we did too? Okay.
Yeah, I think I was.
Were you? Okay. It'll be a little reminder then. So this will help. There we go. So this is a short video about the Maya people, who they were and are.
The Maya. They're considered one of the most advanced civilizations to have existed in the Americas before the Spanish conquest. But who exactly were the ancient Maya people, and what led to the collapse of their civilization? As early as 1800 BC, the Maya had begun settling and established villages in what is today Mexico and Central America. Maya civilization peaked from 250 to 900 AD, during what archaeologists call the Classic period. More than 40 cities flourished throughout the region, with populations as large as 50,000. The Maya built magnificent urban centers consisting of stone structures, including pyramid temples that were central to Maya religious practices. In addition to these impressive city structures, agriculture played a key role in Maya civilization. Corn was one of the predominant crops. The Maya creation story tells of nature gods, the basis of Maya religion, who created humans out of yellow and white corn. The Maya also made significant advancements in mathematics and astronomy. They invented the concept of zero, and they developed an accurate calendar system. Used to guide the Maya agricultural cycles, the calendar was based on observations of the sun and sky over thousands of years. The Maya also developed the only known system of writing in Mesoamerica. Much of what we know about ancient Maya civilization comes from deciphering hieroglyphic characters inscribed in pottery, stone slabs, and other ruins discovered at ancient sites. Hieroglyphs have revealed that, despite the Maya's ingenuity and agrarian lifestyle, conflict was prevalent among some Maya city-states as they battled for control of the region.
Meaning that they were going to war with each other
Throughout much
a
of the
lot.
Classic period, the city-state of Tikal, located in modern-day Guatemala, reigned as the closest thing to an empire in Maya history. But for a period of roughly 130 years, the Tikal people were overtaken through force and diplomacy by the Kanul, a rival kingdom. Toward the end of the Classic period, around 900 AD, most Maya cities had collapsed. Among the theories are warfare, a volcanic eruption, and, perhaps most likely, drought. However, archaeologists still debate why, as new evidence continues to emerge. Despite the decline of ancient Maya civilization, the Maya people have by no means disappeared. More than 7 million Maya are estimated to be alive today in their indigenous homelands and around the world. While they participate in modern global life, they continue to follow agricultural and ceremonial practices of their ancestors.
Okay, so that was just a brief overview who the Maya were and are, right? Just because they don't build giant pyramids and cities anymore doesn't mean they don't live there. So they still build cities, they're just more modern. Yeah. I
No. You are not allowed to go to the bathroom.
Good thing she's not in charge, huh?
Never.
You're gonna
Hold it.
ever?
Never.
Look at that.
The Maya.
Don't start again. Okay, so now we're going to teach you how to count to 20. For those of you who remember this, don't spoil it for them. Base counting systems, okay? A base counting system is what quantity do you count to before you start again? So, we have a base 10 counting system. Decimal, right? Like in Spanish, diez, right? We count to 10 and start again. 0, 1, 2, 3, 4, 5, 6, 7, I missed one, 7, 8, 9, right? So we count to 9, that's 10 digits, and then we do 1, 0, 1, 1, 1, 2. Same thing, every 10. We count by 10s. Why do we count by 10s? You don't remember? Who knows why we count by 10s? Why don't we count by 5s? Why don't we count by 13s? Why do we count by 10s? Because we have 10 fingers. Thank you. I wasn't just dancing for you.
That was a guess.
You were correct. I was trying to give you a clue with my dancing here, but you didn't. 10 fingers. That's it. So you can imagine an alien civilization where they have 8 fingers. You'd probably count 8 before they start again. You can imagine aliens that had 12 fingers, 6 fingers on each hand. Maybe they had 3 fingers. Base 6 system, right? You count to 6. So there are other ways to group numbers to count them. One of them is binary. You heard of binary? What's binary? 0, 1, 0, 1. It's the basis of all computer. Basically, if it weren't for binary, computers wouldn't work. So to make this rather boring image, the computer several million times a second is going 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 0, right? It's literally just on or off. It's called a logic gate. And so millions of times a second, the computer is doing that very, very simple counting. And with lots and lots of layers of code, you're able to get Netflix and, Fortnite. Base 3, trinary. Can you think of something that happens 3 times before we start again? Count 3 things, and you start again. And you can cook, bake. Cooking and baking? No? A little bit? No? How many teaspoons in a tablespoon? You can just make a guess based on what base system we're doing. 3, thank you. 3 teaspoons to a tablespoon. It's a base 3 system. How many feet in a yard? We didn't move on to base 4 yet, though. It's 3. 3 3 feet in the yard. If you ever notice that the floor tiles are exactly a foot long?
Nope.
They are. The floor tiles are exactly a foot long. So this right here is a yard. Okay, so if you ever need to measure something, you can use the floor tiles. Sure.
I'm 3 yards away from you.
Here's an easy one. Base 7, septenary. You use this all the time. You use it, I don't know,
Days.
every week, right? 7 days in a week. You count 7 days and we start again.
What? I thought it was 9 days in a week.
You can make it. Wouldn't it make more sense?
Weeks.
But wouldn't it make more sense if we had like 5 or 10 days since we use a base 10 system? Why don't we use 7 days in a week? Who came up with that? I don't know. Good question.
I did.
Now, this is, besides base 10, the next most common. And this one you might be able to think of some offhand.
Yeah.
Months in a year, thank you. We have a base 12 month system. Duodecimal, count to 12, we start again. What else you got?
The number of animals in that Chinese race.
What's that?
The number of animals in that Chinese race.
Oh, the zodiac has a base 12 animal system. Thank you. Would have been 13, but the cat got the just short end of the stick, right? Can you think of another thing we count to 12 and start again? I'm going to give you a hint. What's that round thing on the wall? We count to 12, we start again. Can you think of another measurement?
Ooh, inches and foot.
Inches in a foot, 12 inches in a foot, that is correct. How about when you buy eggs? We buy eggs by the dozen.
14.
By the 14. Well, you can sometimes get a baker's dozen of 13 donuts, right?
Oh, no, I like a baker's and dozen of 14, a bonus.
Like the bonus baker's dozen? I'm not familiar with that one. You must go to a really good baker.
Yeah.
So, these are different ways of counting. You don't just have to count to 10 and start again. The Maya counted to 20 and started again. It's called the vigesimal system. We'll get back to that in a second. But again, it's not the only way to count. You don't have to just stick to your fingers. You can count to 27, a heptavigesimal system. There is a cultural group in an island called Papua New Guinea. It's north of Australia. It's a great big island. They have one of the most incredible densities of languages in the world. It's this island that's probably about the size of California, and there are like 1,000 languages spoken there. It's insane. One of those cultural groups called the Oksamin, they count like this. They use the joints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Center point is your nose for 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And then you can start again. Right? So 10 is not the only way to count. You can count to 60.
Ooh.
Can you think of something? And you do. Every day. I'll give you a minute to think about it.
We can use our toes, so we only have to do half the work.
A third of the work, yeah.
Minutes and an hour.
Minutes in an hour, 60 minutes in an hour. And I'll give you a second to think about the other one. Yes?
60 seconds in a minute.
Seconds in a minute, thank you. 60 seconds in a minute, 60 minutes an hour. You ever wonder why?
Yes.
Yeah? I'll tell you why. Because 3,000 years ago, the ancient Sumerians counted to 60 before they started again. So they didn't count to 10, nor 20, nor 27. They went digits all the way to 60 before they cycled back through. And so they decided that we would have, they were the ones who said, okay, 60 seconds in a minute, 60 minutes in an hour. And that's why we use that, because 3,000 years ago, they liked this base 60 system. And it's actually a pretty good system, because it gives us the base 360 system, the tricentos hexamagesimal. And you know what that is? What do we get? What do we divide by 360? Or what is it?
It's in a circle.
360 degrees in a circle, right? Yeah.
Wait, no. Never mind.
What were you going to say? Go ahead, say it. I know what you were going to say. Go ahead.
Days in a year.
Days in a year. Keep that in mind, because it's going to be important in a minute. But base 360 is actually really cool, because 360 is probably the most beautiful number I can think of. It is a beautiful mathematical number. I mean, it doesn't look like much, but 360 is divisible by everything. You can divide it by 2, you can divide it by 3, you can divide it by 4, you can divide it by 5, I think 6 and 8, 10, 12, 16, 20, 30. So this is a beautiful number because it is easily divisible by a lot. Not by 7, unfortunately. Not much is divisible by 7. So the Maya with their base 20 system counted this way. 0 was represented, in this case, this is a glyph that looks like a cacao bean. It's meant to look like a cacao bean.
I thought it looks like a chocolate bean.
That's exactly what a cacao bean is.
Yes, I know.
Yeah, okay.
I like to call
I've
it
had
chocolate
people
bean.
say it looks like a loaf of bread.
It also looks like a cockroach.
The legs had fallen off, yes, perhaps. Right, there's your brain finding patterns, right? You're looking for trying to figure out what it is. So the 0 then would be represented by this, but you'll also see there are other glyphs that represent it. Now, to count, 1 dot is 1. 4 dots is 4. It's pretty simple. You get to 5 and it's like a tally mark, right? The bar represents 5. 5 plus 4, 9. 2 times 5, 10. 3 times 5, 15. 5, 10, 15, 16, 17, 18, 19, right? And now we are at the end of our counting cycle. Yes, ma'am?
Wouldn't it be a base 5? Because then like they do dots and then a line and then more dots and then a line.
That's a really good question, but I'll show you in a second why it's not a base 5 system. That's a really good question, because it does kind of seem like, well, they get to there and they start again, but they don't. Let me show you why. Yeah.
For the 0, it also looks like a roll of foley.
It does actually. So, when we count, we have our 1s place and our 10s place, right? Pretty simple stuff. This represents one group of 3 groups, 3 1s. This represents one group of 10s, right? For the Maya, 5, 10, 11, 12, 13. Okay? Straightforward. But let's say I want to count to 33, our first number beyond 20. So instead of doing 1s and 10s, because we're counting by 20s, we do 1s place and 20s place.
Wait, what about
The
20? What was the
20s
symbol for
would
20?
be above the 1s place. Instead of next to it, it's above it. So if I want to write 33, 120, right? This is worth 20 because it's in the 20s. 120 plus 13, 33. Pretty straightforward? Yeah.
Is the dot just like the 1s the same symbol for 20 annual? Wait, what?
Well, like when we put a 3 here, it doesn't mean 3, right? It represents 30. So when they put a single dot here, it doesn't represent 1, it represents a 20.
Oh,
Right? So if we had a 1 here, it wouldn't represent 1, it would represent 10. So same thing except above.
What is the symbol for 20? It can't be the same as 1, right?
This is 20. And if you just had a 0, it would be the dot and then the 0 below it. If it were just 20, it would be the dot with a 0 below it. Does that make sense?
No.
Okay, let's try it this way. 429. This is an easy one. Because when we talk about places, 1's place, 1 times 10 is 10. 10 times 10 is 100. So this is our 1's, 10's, 100's place. 1's, 20's, and then 20 times 20. 400. So instead of 1's, 10's, 100's, 1's, 20's, 400's. So to represent the number 429, we would do one group of 400, one group of 20. Now we have 420. And we fill it in with a number 9 at the bottom. Okay? Same as, really it's the same way we think of it, except that instead of each representing by 10s, it's by 20s. Base 20 system. And this, Bobby, is why it's not a base 5 system. Because when you need to write bigger numbers, we're going by powers of 20. Okay? Does that make sense? And so the Maya weren't messing around. The next one up would be what? Instead of
1,600.
1,000, it'd be powers of 20. The next one up, we have 1,600 in our system. Okay, that was easy. Let's step it up there. 5,125. To do this, we're going to start with our. I'm going to press a button and the whole thing's going to turn off. What did I push? I pushed the B. Oh, B makes it go blank. You learn something new every day. Okay, so I meant to hit the space bar. So, up here, we got our 400s. This bar represents 5 groups of 400. 5 times 400 is? 2,000, because 5 times 4 is 20, plus the zeros back on, we have 2,000. This is 2,000, so what's the total number? 2,000. Here's another 2,000, right? So these two bars represent 4,000. What's that?
The whole number is 4,800.
4,800. 2, 4,000 plus another 4 and another 4. This would be 800. This in our system would be 4,800. Yes?
Say if they have a sheet of paper, somebody writes a number on it, it's that number. How would they know if it's the 2,000 or
Because of the way that they're ordered, one above another, right? Like we orders ours left to right, they order their top to bottom.
Oh.
Okay? And it was also based on context where the other glyphs are, because these always were next to glyphs in their math. Okay? So, but if I added one more dot, I'd get to 5,200, and that's too much. So now I gotta come down to the next group, which is 20s. 5 times 20? 100, right? 100, 200, 300, 320. 4,800 plus 320. 5,120. To complete the whole thing, just add a 5 bar at the bottom. 400s, 20s, 1s. Now, if you kind of think this is interesting, in the assignment that I put out this week, there is a link to where you can learn a lot more about how to do this, and you can learn how to add and subtract using base 20. It's wild. It's pretty cool. It is hard, and it's hard not because addition and subtraction is hard, but because how long have you been using a base 10 system?
My whole life.
Your whole life. How long have you been using a base 20 system?
11 years.
Right
Like,
now.
about 11 minutes, right? So it's the sort of thing where if you used base 20 your whole life, and tomorrow someone tried to teach you the decimal system, you'd look at them like they were crazy. It wouldn't make any sense. But the more you use it, the more it makes sense, and you get used to it. All right, so we'll move into the Maya calendars now. The Maya actually have 20-odd different calendars. We're not going to do 20 calendars. Don't worry. We're going to do 3, which basically make 4. We're going to talk about the Hob calendar, the 360-day solar calendar. 1 year, right? 360 days, right? Correct. Wrong. Year has 365. Where'd those 5 days go? You're in them right now, actually. I'll tell you about it in a second. Then we have the Tzolk'in, a 260-day calendar. Slap those two together, and we have the calendar round, a calendar which circles around every 52 years. And then we're going to start with, actually, the long count, a calendar that counts 5,125 and a third years. This is how the long count works. This is today's date in the long count. Okay? The first digit represents the day, the kin. Okay? So every day this goes up by 1. When we get to 19, the next day will not be 20 because it's full, right? 0 through 19 is your 20 digits. When this gets to 19, the next day will be 0 again. The 20 will be carried over, and this will go up by 1. So the next one over, the Winal, this goes up by 1 every 20 days. Okay? So it's almost like a long week, a short month. So, goes up by 1 every day, goes up by 1 every 20 days. The next one is 20 days times 18. So this will go up to the number 17. The next day will be 0. It'll reset again. 20 times 18 is 360. There's your year, right? Days, months, year. Close to it anyway. Now, when this one reaches 19, it'll stop, it'll be full, and it'll set back to 0. So every time this goes back to 0, this can go up 1. Which means that this next one, the Katun, will only go up by 1 every 7,200 days because 360 times 20 is 7,200. Meaning that this will only go up by 1 every 20 years or so. Okay? Now, so, goes up 1 per day, once every 20 days, once every 360 days, once every 7,200 days. Yes?
What would happen if all of them are 19 and then the day one turns to 20?
I'm going to get to your question in just a second. That's an excellent question. Now, when this gets to 19, the next time it sets will be back to 0. You will carry all those days over, meaning that this one last year, the back tune, will only go up by 1 every 144,000 days, or almost every 400 years. Now, no one lives long enough to make sure that that goes up. So this would be a tradition that the calendar keepers would pass on generation to generation, and many generations on, because the long count only goes up to 13 baktuns. This recently just reset in the year 2012. When it started was back in the year, for us, 3,114 BC. 5,125 years ago. So the next time this reads 13, 19, 19, 19, 19, right? The next time this
It'll be the
resets,
zero.
it'll be the year 7,100 something.
Oh, that's okay, because I'll
Right?
be around to look at it.
But 5,000 years ago, Maya timekeepers were keeping track of this, and they are still keeping track of this. It's a long tradition. All right, we'll dial it back a little bit to something a little easier to follow. The Hab, this is the solar calendar, right? They would do months, 18 months of 20 days. Problem is we're missing those 5 days, aren't we? You are currently in the last 5 days of the Maya calendar year. I couldn't have worked it out better. Total accident. You are in what's called the Wayeb. It's a 5-day month. And Wayeb means the nameless days. This was the most unlucky 5 days of the year. If you happen to be born during the Wayeb, you were considered to have bad luck the rest of your life. All right? So the Wayeb was like the last 5 days of the year, and everybody just kind of hunkered down and hoped nothing bad happened, and then they could move on to the next month, 5 days later.
They
So
should make a
today,
movie about that. They should make a movie about that.
today is 0 Wayeb. We got 5 more days. Now this glyph here represents 0. It doesn't look like a cacao bean. It's a different way of writing it.
It's a
And this
cat or a
here
hot dog.
is the Wayeb. Questions?
What in like our type of date is the YM?
We don't have a Wayeb.
No, like it's for 5 days. What in our date is that 5 days?
It's today. Today is 0 Wayeb. Tomorrow will be 1 Wayeb.
So it ends on.
So literally this is the last 5 days of the Maya year. You're in it right now. The Maya Hab year, right? Because there's also the Solkin. This is a 260-day calendar. So this date, right, of today of 0 Wayeb will occur 365 days from now, right? It'll occur this time next year. The Solkin is different. It's 20 days and 13 numbers making 260 days. This is based off of where Venus rises and sets. Remember I said how Venus represents Kukulkan, the feathered serpent? That's what they were watching. This calendar is related to the rise and set of Venus. Today is 5 Kaban. Now you'll see here, this is the bar. And when they wrote the glyphs, they actually wrote the numbers side, they put them vertically. All right? 5, and then here's the glyph for Kaban. This will not occur again until 260 days from now. But the Maya were not satisfied with that. If we take the date of 0 Wayeb, 5 Kaban, both calendars at the same time, today's date will not repeat again for 52 years. Meaning that if you have the unfortunate luck of being born today, your birth dates on the Hab and the Solkin will occur when you're 52. And the Maya believed that when you turn 52, you will be an elder. It would be like a revered status to reach 52. So even though you're born in the Wayeb, you were probably lucky to make it to 52. But not good enough, right? Because we got our long count calendar. And we got our calendar round to 52 years. This date today, 13-08-6-17, 0 Wayeb, 5 Kaban, will occur again. But it won't occur again for another 250,000 years. And the Maya were aware of this. They were using their base 20 system to calculate dates out millions of years from now. They love their math. They love math, and they love being able to predict the future with their calendars. So, if you would like, I have, if you would like to make your own Maya calendar round. I don't have a long count calendar, but this right here is a copy of the base 20 system, if you forget your numbers, and the calendar. If you want to see how to make it and how to use it, there is a video I made in the assignment that teaches you how to make it, how to put it together. It's not that hard. And then how to use it. You will end up with something that looks a lot like this. Right? They're just stacked. You'll notice there's a paper fastener I stuck in the paper in the staple. That's just to kind of keep that in there. So today's date of 5 Taban 0 YN. 5 Taban 0 YN. Tomorrow would be 6 Etznav 1 YN. Right? That's okay. If you move it each day, you don't have to remember it. If you forget, if you mess it up, there's a link to a website that will tell you the current date in Maya, on the Maya calendar round. Or you can come over here as you pass by, and you can reset your calendar based on mine. I will be your timekeeper. Right here is the Maya calendar, and I try to keep it up to date so that each day you can see when the calendar round is at.
Oh, I have a question that's unrelated to this right now.
Okay. Okay. Thank you for warning me ahead of time.
After COVID, is the enrichment thing still gonna be right here?
No. They're gonna want their.
Oh yeah, the lunch.
They're gonna want their lunch. You're gonna want your lunchroom back too. Aren't you tired of eating lunch in your classroom?
Yeah. Next year we'll be at the other school.
Yeah. Well, that's true. You will be, won't you?
What did the Mayas do on this